This is Module 3 of the Lean Six Sigma Yellow Belt course, and we're going to dive into just a little bit deeper of what is Six Sigma. And again, keep in mind that we're in this to certify the best for process improvement. Six Sigma is a structured, data-driven methodology for eliminating variation from processes, products, and other business activities, all the while having a positive impact on financial performance. So there's some ideas about Six Sigma out there, and a couple of them are this: perceived to be a business system that improves the bottom line. Certainly should do that. Perceived as fitting naturally into the business systems of most companies because they are data-driven. Six Sigma perceptions also include that they are perceived as being more easily and more successfully launched than traditional total quality management programs. TQM is perceived as a technical system owned by a bunch of technical specialists. So what are the benefits of adopting Six Sigma methodology? One is the enhanced ability to provide value to the customer, enhanced understanding of key business processes in objective terms. We want to reduce variation, and really variation is a synonym for quality. And we want to improve the profit and performance of our business system or our company. So Six Sigma methodology focuses on customer knowledge, that is what is critical to quality as expected by the customer. And then what are our core processes? We have key business processes that are designed to deliver value directly to the customer. And of course, we want to have accurate performance measures or scorekeeping of these ideas. The Six Sigma methodology is based on statistical process control techniques, data analysis, project management, and of course systematic training or development of all participants and stakeholders at all the different levels. Here's the ultimate goal for Six Sigma, and that is that we would be able to only have 3.4 defects per million opportunities, and that's over the long haul. And this is kind of a chart which shows what the difference in each Sigma rating of our process would be. At a Sigma 1, we have 690,000 defects per million opportunities. You get that? Almost 700,000 defects per million opportunities. That means we're getting a 30% yield out of our process. Sigma 2 means that we have 308,000 defects per million opportunities. That's a 69%, quite an improvement. About Sigma 3 has 66,800 defects per million opportunities. That's getting into the 90s, 93.30%. Sigma 4 is 6,210 defects per million opportunities. We're right at 99% now, almost 99.5%. Sigma 5, we have only 320 defects per million opportunities. That's 99.98%. That sounds pretty good, okay? But actually, we're looking for Six Sigma. That's 3.4 defects per million opportunities, or 99.9997. Now, this is how we end up comparing different processes together. We use this particular measure. It's defects per million opportunities. We can tell you how efficient and effective our process is in delivering the quality expectations that we have for it. And here's a key understanding that translates these ideas of statistics into dollars. And it proves just one Sigma can result in about a 10-fold reduction in the number of defects. Look at this. At 3 Sigma, we would have 66,800 defects per million opportunities, costing $10 per item to fix. That means our cost would be $668,000 to fix. We just improved by 1 Sigma. At 4 Sigma, we would only have 6,210 defects per million opportunities. If it costs us $10 a piece to fix them, then we're only costing ourselves $62,000 compared to that $668,000. That's why we say one Sigma shift will easily give us a tenfold improvement. But here's why 99% is not good enough. And by the way, this was a standard that was set in World War II for all the processes that were going. But if we're working at 99% defect-free, that means at least 200,000 wrong drug prescriptions will be given out each year. Okay? Out of all the landings and takeoffs, we have 2 short or long landings at major airports each day. We'll have 5,000 incorrect surgical procedures done every week. We'll have 20,000 lost articles of mail per hour. We'll have unsafe drinking water for almost 15 minutes each day. And we'll have no electricity for almost 7 hours each month. And we'll have 50 dropped newborn babies each day. So you see, 3 Sigma, which was about at 99% defect free, is not good enough for most of the processes that we really care about. So 6 Sigma projects are selected based on their ability to contribute to and enhance an organization's ultimate financial performance. The project methodology is divided into 5 phases for 6 Sigma, known as DMAIC, or Define, Measure, Analyze, Improve, and Control. Notice this is pretty similar to the Plan, Do, Study, Adjust cycle that we have in lean thinking. Okay, under Define, we identify the problem or the project, define the requirements, and establish goals that we want to achieve if we take on this improvement project. And of course, we have to analyze measurements within ourselves. We have to have objective data to tell us things. So we gather information about our current process, define and measure the key process steps and inputs, and refine the problem statements and goals within this phase. In the analyze phase, we identify potential root causes of our problems and validate those cause and effect relationships. We identify the vital few root causes. Now we're going to come up with improvement ideas and test those and make selections and implement. So in our improve phase, we implement solutions to address root causes of the problem. We test those solutions. We measure results to make sure we got the improvement we're expecting to have. And next, we want to control or to sustain the gains. We evaluate and monitor their improvements, and then we make adjustments as we need to. And we establish standards to make sure we don't slip back. We have sort of a core set of 6 Sigma tools that we use within the DMAIC phases to help us really get an understanding of our processes and look for opportunities to improve. We use process maps, cause and effect diagrams, a rigorous process of evaluating potential problems and doing risk analysis called failure modes and effects analysis. We do measuring systems analysis. It's amazing how many times measuring systems aren't reliable or consistent. We do process capability studies. We do multivariate studies. We design experiments. Basically, we build statistical models of our process, and then we do experimentation with those models to help point and indicate where the better opportunities for improvement are. And then ultimately we build our control plans, and we want to make those objective and data driven, and so we call those statistical process control plans. 6 Sigma participant levels. We typically have yellow belts, green belts, black belts, and master black belts, and the real difference in those is the level of engagement and participation. But more than that is what the expected returns on projects that they undertake are. Starts with relatively little amounts we expect to get from yellow belts. With green belts, it jumps up to $10,000. Black belts up to $100,000. And on master black belts, they're doing the bigger mega projects, and we're looking for $1 million savings. So, at the end of it all, 6 Sigma seeks to reduce the variation or the variability that's present in all processes. And again, as we said early on, variation is really a synonymous term for quality. Six Sigma project consulting based on their ability to contribute to and enhance the organization's financial performance. And we expect the results to come out as improving profitability by eliminating waste and reducing variability. And so this concludes Module 3.